So question 1 was asking you about the type of particles that are present in different scenarios. I'm looking specifically at question 1E, which says that the atoms join together to form compounds when you have non-metals react together, when you have a metal and a non-metal react together. So some of the questions that you could be asked are definitions of the different keywords such as element, compound and mixture. So an element is a species which has one type of particle. Now for most elements that particle is an atom because most elements are monoatomic. That means that they don't have any number after them. So for example, sodium has the symbol Na. There are these 7 exceptions: fluorine, oxygen, bromine, chlorine, hydrogen, iodine and nitrogen. The way I remember those is by the anagram FOBGYM. Because they have a little 2 after them, we call them diatomic. So even though they are elements, they are made up of molecules, not atoms. So a potential question may be looking at which elements are made up of molecules. In the other scenario, in the question, you are looking at compounds, and you know from your structure and bonding topic that there are 2 types of compound that you can have. One being covalent, which is a non-metal, and one being ionic, which is a non-metal. So the question which said compounds formed by 2 non-metals reacting, that was testing whether you knew that was a covalent compound. The question whether metal and non-metal reacting, that was testing whether you knew that was an ionic compound. So obvious potential questions you could be asked are what the definition of a covalent bond is, which is an attraction between the positive nuclei and a pair of shared electrons. What the definition of an ionic bond is, which is an electrostatic force of attraction that results from a positively charged ion and a negatively charged ion being attracted to each other, and those ions are formed between a metal and a non-metal due to the transfer of electrons. So we can see there that one of the electrons is represented as a dot to show that that has been transferred from the positive ion. Obviously, in covalent bonds, you could be asked to draw dot cross diagrams. Similarly, for ionic compounds, you could be asked to draw dot cross diagrams. You need to make sure that you represent the electrons with different codings. So here I've drawn hydrogen, so atom A has a cross, atom B has a dot, and you need to make sure that the number of electrons in total adds up to the maximum number of electrons that can be in that shell. The way you work out the number of maximum electrons in a shell is just how many elements are in that row. So hydrogen's in row 1, there are 2 elements in that row, hydrogen and helium, and therefore the maximum number of electrons in hydrogen inside a shell is 2.